Hey mathematicians, we are going to get into compound inequalities today. So we've been talking about how to graph an inequality, if it's a filled in circle or an open circle, if you shade to the left or the right. Well, today we're going to talk about compound inequalities. And compound inequalities have two dots on your graph, and they shade in two directions. They either shade together or they shade apart. And so we're going to talk about how to determine that. We have two types of compound inequalities. We have an and statement and we have an or statement. Our or compound inequalities shade apart. All right, just like that. Okay, it's either here or it's here. And statements shade together, meaning it has to be less than this side and more than this side. It has to fall in between those parameters. So we're going to go through and discuss how to solve them and then how to graph them. All right, so when we take a look at these, we have three different ways that they're written out. This first statement and this last statement are the examples of and inequalities and compound inequalities. The one in the middle is or. So let's walk through how to solve these out. Taking a look at that first one, we have -3 is less than x, which is less than or equal to 5. All right. So when we look at that, that's already solved because solution means that you need to have the x by itself. And so it is. So then my next step is to graph that out. So instead of only having one important number, like we did in the last practice, we're going to have two important numbers. So in this case, it's -3 and 5. Those are my important numbers. -3 is an open dot, and 5 is a filled in dot. And again, it has to do with the sign. Okay, one is less than and one is less than or equal to. And statements come together. And so I am going to shade in between. That's what the graph of an and statement looks like. Two dots, shade in between. Or statements have two dots, but you shade apart. Okay, so when I look at these or statements, my lesser number on the left, my greater number on the right, always. Okay, so if x is more than 4, that tells me it's an open dot. Or statements shade apart. Here's the or statements shade apart. Okay. So when we have an or statement, they're apart, and statements are together. Typically, the and statements won't have the word and in them. They're just going to be joined together as it is in the first example. Sometimes we will have the and statement in between, like we have here. So again, we have two numbers to plot down. We have the lesser number on the left. We have the greater number on the right. Open number or open dot on 9 because it's x is more than 9. Filled in dot on 13 because it's less than or equal to. And because it's an and statement, we shade in between. And come together, ors go apart. Now, how do we solve these? Okay, we just talked about how to graph them. Now we're going to practice solving and graphing them. The whole goal is to continue to get the variable all alone. Same idea that we've been talking about with equation solving and so far with inequality solving. So when I look at this, to get that z all alone, what I need to do is I need to subtract 2 from that. Now, there are 3 parts to this inequality. There's the front, the middle, and the end. So I need to subtract 2 from the front, the middle, and the end. All 3 parts. Some students find it helpful to draw the lines down for both inequality symbols to kind of break it apart. You do what works for you, okay? So 5 is less than z, which is less than or equal to 9. Now I have the z by itself. I see that it's an and statement because it's joined. And now I can go ahead and graph it. I have 2 dots on my graph, 5 and 9, lesser number to the left, greater number to the right. In this case, the 5 is open because it's less than. The 9 is filled in because it's less than or equal to. And because it's an and statement, we shade them together. And statements are shaded together. That's solving and graphing a compound inequality. Let's take a look at this next one. Again, our goal is to get x by itself. Okay, so the first thing I'm going to do is add 8 to both sides. So I have that 6 is less than or equal to 3x, which is less than or equal to 18. And again, if you find it helpful to draw the lines down to show the 3 parts, totally cool. Do what works for you. We want you to be successful. You don't have to do it my way, just the mathematically sound way. And so then we have 3x in the middle. Again, my goal is to get that x all alone. Same goal with solving equations. So I'm going to divide everything by 3. And so I end up with 2 is less than or equal to x, which is less than or equal to 6. So I'm going to shrink this down just a little bit. There we go. So then I'm going to put 2, 6, filled in circles. It's an and statement, so I shade in between. All right, I'm going to work through this next one together. It's a little different than the other ones we've done. See if you can figure out why. All right, so I'm going to start by adding 13 because my goal is to get x all alone. Add 13, add 13. So I end up with 9 is less than or equal to negative 3x, which is less than or equal to 13. Now I need to divide everything by negative 3. And you remember what we talked about when you multiply or divide by negative 3? You need to flip the signs. You got to flip those inequality signs. So when I do that, when I divide everything by negative 3, I get that negative 3 is greater than or equal to x, which is greater than or equal to negative 13/3. All right. Now, negative 13/3, that is also negative 4 1/3. All right, so I'm going to put these on my number line, negative 4 1/3, negative 3, lesser number to the left, greater number to the right. They're both filled in. And it's an and statement, so I shade in between. So that's what it looks like. Okay. And now we're going to do an or statement. So I'm trying to give you a different example of each kind that you might see: a one-step, a two-step with a negative, or an or statement. Teachers love or statements. You know why? Because we like deals. And this is a 2-for-1. You have to solve 2 inequalities in one problem. Teachers like deals. We like 2-for-1s. That's what this is, okay? So I'm going to add 7 to both sides. I'm just going to solve this first one. Okay, it's greater than 32. I'm going to divide by 4. K is more than 8. Or, now I need to solve my other one. Subtract 12 from both sides. I've got negative 9k is more than 18. I'm going to divide by negative 9. And when you multiply or divide by a negative number, you need to flip the inequality sign. So now my inequality sign is going to be less than, so k is less than negative 2. So either k is less than negative 2 or k is more than 8. It's an or then statement. It shades apart. All right. All right. Now this next one, what we're going to do is we are going to write the compound inequality for these. All right. And then it's going to give you some time to work. So this statement, this first one, it's shaded together, tells me it's going to be an and. So I'm going to put my lesser number to the left, my greater number to the right, and my variable in the middle. When I put in the inequality symbols, they're going to go the same direction. And I have to pay attention if it's and, like filled in, including it, or not filled in. In this case, they're both filled in, so they're both going to be less than or equal to. So 1 is less than or equal to x, which is less than or equal to 4. That's the compound inequality. Okay. Let's go to this bottom right one. This is also an and statement. When you do an and statement, your lesser number to the left, your greater number to the right, okay, and that's going to be 3, your variable in the middle. Lesser number to the left, greater number to the right, variable in the middle. The -3 is less than, and the +3 is less than or equal to. So -3 is less than x, which is less than or equal to 3. Okay. All right. 2 more. Let's go with the or statements. All right. So with the or statements, we write the inequality for this one, then we write or, and then we write the inequality for this one. So on the left side, x is less than -1. It's less than because it's an open circle, or x is greater than 2. All right. So that's going to be it's actually going to have the word or in it. Okay. It's one of the few times that it's okay to write the word or in your answer is when you're doing or equations. So x is less than -2, or x is greater than or equal to 1. Again, one of the few times that you can add or to your statement. All right, I wish you a good afternoon, evening, morning, whenever you're watching this, and we'll chat with you soon. Take care. Bye-bye.